This is Examples in Music for Module 47. 47.1 says calculate addition and subtraction using mod 12 arithmetic. We're going to use mod 12 arithmetic for all sorts of interval calculations when dealing with integer notation analysis. Mod 12 arithmetic means that we're only going to use 12 different integers. For our purposes, those integers will start with 0 and go up through 11 with no negative numbers. When using mod 12 arithmetic, we will never have a number that is higher than 11, and we will never have a number that is lower than 0. Many find using the clock face to be very helpful when doing mod 12 arithmetic. When assigning numbers to the clock face, as well as using integer notation in music, we're going to replace the number 10 with the letter T and the number 11 with the letter E. This helps us not confuse the number 11, which is representing the pitch class B, with two instances of the number 1, which would indicate two C sharps. Same goes with 10, not confusing the number 10 with a separate 1 and 0. In mod 12 arithmetic, some calculations are the same as normal arithmetic. For example, 4 plus 5 equals 9. On the clock face, if we start on number 4 and go clockwise for addition, 5 spaces, 1, 2, 3, 4, 5, we end up on 9. In normal arithmetic, 10 plus 4 equals 14. But the number 14 violates our mod 12 rule of having a number that is higher than 11. In mod 12 arithmetic, there are a couple ways to come up with the correct answer. 1. If we're ever faced with a number that is larger than 11, we can simply subtract 12 from that and we'll have the correct number. Therefore, 10 plus 4 does not equal 14. 10 plus 4 equals 14 minus 12, which is 2. That may seem confusing at first. Using the clock face is often a great tool that makes it make more sense. If I'm starting on 10, or T, and I want to add 4, I'll go around the clock face clockwise. 1, 2, 3, 4. And we arrive at the number 2. Therefore, 10 plus 4 equals 2, using mod 12 arithmetic. And a better way of writing this equation would be to replace the number 10 with the letter T. T plus 4 equals 2. 6 plus 6, starting on the number 6 down here, plus means goes clockwise, and goes 6 spaces. 1, 2, 3, 4, 5, 6. Normally 6 plus 6 equals 12, but in this case, 6 plus 6 equals 0. 5 plus 9. Start on 5 and move clockwise 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 plus 9 equals 2. Let's do one in subtraction. 4 minus 7. In normal arithmetic, this would give us a negative number. In our mod 12 arithmetic, we said that we'll have no numbers that are lower than 0. If I start on 4 and subtract 7, I want to go counterclockwise around the clock face. 7 spaces. 1, 2, 3, 4, 5, 6, 7. 4 minus 7 equals 9. An example of how this might work in music is if we were starting on the note E, which in integer notation is a 4, and then we need to make a calculation of the next note being lower 7 half steps. Starting on 4, subtracting 7 using mod 12 arithmetic would tell us that that resulting note would be A, or integer notation 9. Objective 47.2 says, distinguish between the terms pitch class sets, ordered pitch intervals, unordered pitch intervals, ordered pitch class intervals, and unordered pitch class intervals. As we said in a previous video, there are a lot of terms in Theory 4 that have very similar words, but they are all referring to things that are slightly different. It's important to keep an organized list with definitions to keep them all straight. Here's an excerpt from a work entitled 3 Piano Pieces by Schoenberg. The term pitch class is a definition we've already discussed. It refers to a pitch regardless of octave. In terms of pitch class, this B natural and this B natural are the same. Within integer notation, we'd call both of these pitches an 11, or to not confuse the number 11 with two individual number 1s, integer notation would label this E. Pitch class sets. Pitch class sets are a collection of pitches that are usually written in integer notation. Pitch class sets are unordered, which means that the order the numbers appear in the set, when written out, does not matter. When we write them down, we put them within curly brackets. Let's say we're analyzing this piece and we wanted to put the notes that are under this melodic line from this B all the way to this E natural within a pitch class set. I'm going to omit these two half notes because I'm going to attribute them as part of this chord here and this chord here for this example. I would first convert the letter names of these pitches to integer notation. This B would be an 11, or E. This G sharp is an 8. This G natural is a 7. This A natural is a 9. F natural is 5. This is a repeated F natural, we will not count it again. And finally, this E natural is 4. So we could put those in curly brackets, the numbers E, 8, 7, 9, 5, 4. If we're discussing them as part of a pitch class set, that order does not matter. The pitch class set 7, 8, E, 9, 4, 5 would have the same content as the previous one in a different order, and they would both be considered the same. This is sort of similar in tonal music when we list a major triad. For example, a D major triad is D, F sharp, A. No matter what order we change those notes, A, F sharp, D, those pitches still are considered making up a D major triad. Just as we often talk about triads in root position, there is a common way when speaking of pitch class sets of ordering the numbers. Even though the order does not matter, we try to list them in ascending order in a way that has the fewest gaps around the clock face. This will be a later objective. Now let's talk about ordered pitch intervals. These are different than pitch class sets. Pitch class sets was a collection of pitches. Ordered pitch intervals are talking about intervals, the distance between two notes. Something that can be confusing in Theory 4 is that when we talk about intervals, we're going to be using numbers to signify numbers of half steps. We have to be careful to keep our numbers straight because we're also now using numbers or integers to identify pitches. So sometimes when we use numbers, we're talking about pitches, and other times when we use numbers, those are representing intervals. Ordered pitch intervals are the distance between two notes measured in half steps, and we use a plus or minus sign to show direction. In this case, the word ordered is referring to the direction up or down matters. In regards to ordered pitch intervals, using a plus or minus sign to show direction, the number 1 indicates 1 half step, the number 2 indicates 2 half steps, the number 3 indicates 3 half steps, and so on. An octave is represented by the number 12, 12 half steps. With ordered pitch intervals, using a plus or minus sign to show the direction up or down, we can have interval numbers that are larger than 12. For example, plus 15 would represent 15 half steps up. The ordered pitch interval between this B and this G sharp would be minus 3. We can use integer notation to arrive at this answer more quickly. This is an 11, or E. This is an 8. 11 minus 8 equals 3. This E natural is a 4. This G is a 7. The distance between 4 and 7 is plus 3. Here we have a G sharp going up to a C sharp. G sharp in integer notation is an 8. C sharp in integer notation is a 1. Because this distance is further than an octave, and we're currently talking about ordered pitch intervals, the distance here would be represented by plus 17. Now let's talk about unordered pitch intervals. These are the distance between two notes measured in half steps, but they do not specify direction up or down. The word unordered in this case refers to not specifying direction up or down. Unordered pitch intervals are often used when naming interval size of two pitches that occur at the same time. Again, these unordered pitch intervals can be larger than 12. An example in this work would be the notes that occur in this chord here and this chord here. When comparing this G flat to this F, the distance between those two notes are an 11. Since they're played at the same time, it would be difficult to distinguish if we're talking about 11 half steps up or 11 half steps down. So the number 11 just means an unordered pitch interval. The distance between this B flat and this A is also that of 11. Two more definitions. Next is the ordered pitch class intervals. Intervals means the distance between two notes. Ordered means the order of the two notes does matter. But when we use the word pitch class instead of just pitch class means the octave does not matter. To find an ordered pitch class interval, we'll convert the pitches to integer notation. Then we'll subtract the integer of the first note from the second note. and we'll use mod 12 arithmetic. Therefore, we will always have a resulting interval number that is between 0 and 11. So we have the number 11 followed by the number 8. To find the ordered pitch class interval, we would take the first number and subtract it from the second. That gives us 8 minus 11. Since 8 minus 11 would give us a negative number, let's add 12 to the 8. We have the numbers 20 minus e, which would equal the ordered pitch class interval of 9. Finally, we have the term unordered pitch class interval. Interval means we're talking about the distance between two notes, pitch classes, which means the octaves do not matter, and unordered, meaning the order of the two pitches, which occurs first and which occurs second, also does not matter. Finding unordered pitch class intervals will always result in numbers between 0 and 6. You can find the unordered pitch class intervals by subtracting the first note from the second note, and by subtracting the second note from the first note, both using mod 12 arithmetic, and then take the smaller of the two numbers. For this first interval, we already said if we take the first note and subtract it from the second note in integer notation, the number is 9. If we take the second note and subtract it from the first, which would be e minus 8, the interval calculation is the number 3. So for these two notes, the ordered pitch class interval is 9, and the unordered pitch class interval is 3.